students. In this video we are going to discuss about equations of motion by calculus method. Equations of motion. Equations of motion by calculus method. Once again, we are going to discuss equations of motion by calculus method. How many equations of motions are there? 4. Now what are that? Point number 1. V is equal to U plus AT. Second one. S is equal to UT plus half A T square. Third one, V square minus U square is equal to 2AS. Fourth one, S nth is equal to U plus A by 2 into 2n minus 1. These are the 4 equations of motion. Now we have to derive these 4 equations of motions in calculus method. Calculus method means we have to derive this equation with the help of integration. Okay? Now we are going to discuss about first equation of motion. That is first equation of motion. First equation of motion or velocity time relation. Velocity time relation. We also called as V is equal to U plus AT. Now go for discussion. Once again I am repeating, we are going to discuss about first equation of motion, velocity time relation, V is equal to U plus AT. Now take a straight line. Initially at a time t is equal to 0, the velocity is u. After some time, the time t is equal to t, the velocity is v. Here the u we can call as initial velocity, the v we can call as final velocity. Now acceleration is defined as is defined as the rate of change of velocity. Therefore, acceleration A is equal dv by dt. Consider this is equation number 1. My dear students, once again I am repeating, acceleration is defined as the rate of change of velocity. Therefore, A is equal dv by dt, equation number 1. Therefore, dv is equal A into dt. Consider it is equation number 2. When time t is equal to 0, velocity is equal to u. When time t is equal to t, then velocity is equal to v. Therefore, integrating equation 2 within above limits within above limits of time and velocity. Therefore, integral u v. My dear students, this is called lower limit. V is called upper limit. Always upper limit minus lower limit. We have to solve the numericals. When time comes, I can explain. Therefore, integral u v dv is equal to integral 0 to t a into dt. Therefore, integral dv is equal to v. Now, we have to take a bracket. Here we have to write lower limit. What is lower limit? U. What is upper limit? V. That is equal to what is integral a into dt? May I write? A is a constant. So I wrote outside. Now what we have? We have integral 0 to t into dt. Remember, if the differentiation is in the form of t, we have to do integration with t. If the differentiation is v, we have to integrate with limits velocity only. If here is x, it should be x. Here is t, it should be t. Okay? Now, here, what is the point I told? At first we have to substitute final limit. after that initial limit or lower limit. Now in the place of v, we have to substitute upper limit, that is v minus is condition. In the v, we have to substitute u, that is equal a into what is integral t dt t. Now what is the limits? The limits are 0 and t. Therefore we got v minus u is equal to a into t within the limits 0 to t. 0 is lower limit, t is upper limit. Therefore v minus u is equal to a into what is the condition? In the bracket t is there. In the place of t, we have to substitute upper limit, that is small t minus is the condition. In the place of t, we have to substitute lower limit, that is 0. Therefore v minus u is equal a into t. Therefore v minus u is equal a t. Therefore v is equal u plus a t. Consider this is equation number 3. This is called first equation of motion. Now we are going to discuss second equation of motion. Second equation. Second equation of motion. What is the another name? The another name is position. Position time. Position time relation. Position time relation. The another one is S is equal ut plus half a t square. So out of these three, whatever it may be, let them be asked by the examiner. We have to derive S is equal ut plus half a t square. Now go for discussion. Velocity. Velocity is defined as the rate of change of displacement. Once again, I am repeating, velocity is defined as the rate of change of displacement. V is equal ds by dt. Consider this is equation number 1. Therefore, ds is equal to v into dt. Consider this is equation number 2. But but v is equal to u plus at. Consider this is equation number 3. Now equation 3 in 2. Now equation 3 substitute in 2. Therefore ds is equal to u plus at into dt. Consider equation number 4. Now take at time t is equal to 0, the displacement is equal to 0. At a time t is equal to t, the displacement s is equal to s. That means when time small t is equal to 0, therefore distance traveled is equal to 0 when time t is equal to t, distance traveled is equal to s. Therefore integrating equation 4 within above limits of time and distance. Once again I am telling, integrating equation 4 within the above limits of time and distance. Therefore integral 0 to s ds, because we are differentiation is the integration limits are distance, therefore the differentiation should be s, is equal to integral 0 to t. What is the equation? U plus at into dt. Once again, integral 0 to s ds is equal to integral 0 to t u plus at into dt. Integral 0 to s ds is equal to u. Now take this one, integral 0 to t u into dt plus integral, take inside 0 to t, what we have, at into dt. Now integral 0 to s ds is equal to, I already told, we are differentiating with respect to time. That means dt should be there. The remaining obviously constant. So remove from this place and write in front of the integration. Therefore, u into integral 0 to t dt plus, here we are doing integration with respect to time. Therefore, t and dt should be here. A should be constant. It should be removed from this place and right in front of the integration. That is a into integral 0 to t into dt. Now go for integration. Integral ds is equal to yes. Now what are the limits? Lower limit is 0, upper limit is yes. That is equal to u into, what is integral dt? Small t. Now what are the limits? Lower limit is 0, upper limit is t plus a into, what is integral t dt? Integral t dt is equal to t squared by 2 formula. What is that one? Integral t dt is equal to t square by 2 formula. But limits as usual 0 t. Now therefore s 0 s is equal to u into t within the limits 0 to t plus a into t square by 2 within the limits 0 to t. Therefore, apply upper limit yes, apply lower limit minus 0 in the place of yes, where minus is condition. That is equal to u in the place of t, apply upper limit t minus 0 plus a into, apply t in the place of this one, that is take 2 outside 2. Therefore t square minus, in the place of t apply 0 square as usual. Okay, once again I am repeating. A I wrote here 2 is a constant, so I taken it out. Now what we have? We have only t square. In the place of t square, at first we have to substitute upper limit, that is t square. Minus is the condition. Now in the place of t, we have to substitute now 0. Therefore I substitute 0 square. Here s is equal to u into t plus a by 2 into t square, because it is 0. Therefore finally we will get s is equal to ut plus half a t square. This is called second equation of motion. This is equation number 5. My dear students, we have to solve the second equation of motion by the calculus method. Calculus method means integration method. However, in this video we discuss first equation of motion and second equation of motion. Thank you very much for watching this video. Thank you.